Hello guys, so in this video we are going to talk about extended Euclid algorithm. So the extended Euclid algorithm is used to find out GCD of two numbers. So the first objective is to find out the GCD of two numbers. By the way, GCD of two numbers can also be found out using the Euclid algorithm. And Euclid algorithm is basically easier than the extended Euclid algorithm. So in a way, what I'm recommending is use Euclid algorithm to find GCD of two numbers, not the extended Euclid algorithm. But the second use case of extended Euclid algorithm is, and which makes it very popular, is basically this help us in finding the additive inverse of two numbers. Additive inverse. Okay, so what do we mean by additive inverse? So let us say, okay, I'm so sorry. Okay, so let us see what do we mean by additive inverse. Okay, additive. So I'll talk in this in terms of GCDs only. Additive inverse is a much broader concept and it could be applied elsewhere as well. But from the GCD perspective, we know that GCD of two numbers A and B can be written in the form of ax plus by. Alright, and we know that x and y belongs to the set of integer. So here x and y are the additive inverse of each other. Okay, additive inverse. Okay, so this is what additive inverse in context of GCD is. So now so let us take some examples and try to find out the meaning of additive inverse. Okay, so let us take an example wherein we want to find out the GCD of two numbers. Let us say 240 and 46. Okay, so 240 and 46. Now we know that the GCD of 240 and 46 can be written in the form of ax plus by. And since A and B are 240 and 46 respectively, so we can also write it as 240x plus 46y. Now what are the values of x and y? Okay. Now the extended Euclid algorithm help us in finding out these values. Now let us see how can one find out the values of x and y using extended Euclid algorithm. Okay. So let us first do this. Let us try to find out the HCF or GCD of 240 and 46. So this will be 5 times. So I think 230. Then this goes 10, and then we 46, 4. This is 6, 10, 1 times 6, 4, 1 time, 2, 4, 2 times, isn't it? And that's how it becomes 0. So this in turn is our GCD. So we know that the GCD of 240 and 46 is basically 2. Okay, so now let us see how can we express it in the form of equation. So what is 240? So what we will do is that every time we will go ahead and express the one which I am highlighted in yellow color in the form of the equation which I am going to write down. So the first thing which we are going to do is 240. So let us express 240. Okay, so 240 is basically 46 times 5 plus 10. This is also known as division algorithm. Okay, let's see. 46 again is basically 10 times 4 plus 6, and similarly, what is 10? 10 is equals to 6 times 1 plus 4, and let's say So we have represented 10, now 6. So 6 is basically 4 times 1 plus 2. Now what is 4? 4 equals to 2 into 2 plus 0. Okay, so we can strike out this equation. We don't actually need this equation. So for our importance, these are the 4 equations which will be used in order to find the in order to express GCD of 240 and 46 in terms of AX plus BY. So let us see how do we do that. So what can we do here is basically, so okay, so this from here we can say that 2 equals to 6 minus 4 times 1, right? Similarly, from here we can say that 4 equals to 10 minus 6 into 1, right? Similarly, from here we can say 6 is equals to 46 minus, let me just delete this, 46 minus 10 into 4, right? And similarly here we can say that 10 is equals to 240 minus 46 times 5. Now let us, so what we will do is this, is basically from here we will replace the values. So here there is a 4. We will replace the value of 4 from this equation, and again we will express it, and then we will get 6. Then what we will do is that we will substitute the value of 6 from this equation over here. So essentially the values will come from here, then to here, and eventually to here. Okay, so let us do that. So let me start with my equation, which is 2 is equals to 6 minus 4 into 1. So I'm starting from the first equation. This is the equation I'm starting from. And what do we know from the above equation is 4 equals to 10 minus 6 times 1. So let us substitute the value of 4 in this equation. So what will happen here? So this will becomes actually 2 equals to 6 minus, and 1 times is basically 10 minus 6. Okay. Now this, let us rearrange this. So this is actually equals to 6 minus 10 plus 6, which we can write it down as 2 times 6 minus 10. I understand that there is an urge to solve this 6 plus 6 equals to 12, but let us not do this. For the sake of extended Euclid algorithm, let us not do this. Okay. Now, so we have broken down our equation from here to here. So 2 times 6 minus 10. Now let us see again this equation. So 6 is equals to 46 minus 10 into 4. Now let us substitute the value of 6 in this equation. So 2 equals to 2 times, what was the value of 6? 6 equals to 46 minus 10 into 4. 46 minus 10 into 4 minus 10. So what will this become? So 2 equals to 2 times 46 minus 8 times 10 minus 10. So we can again rearrange it, and we can say that 2 equals to 2 times 46 minus 9 times 10, right? Let me just make it as 0. 9 times 10. Now let us see. So we have substituted the value of 6. Now this is the value we want to substitute, the value of 10. 10 equals to 240 minus 46 into 5. Okay, so 2 into 46 minus 9 into, what is the value of 10? 246 minus 46 into 5. 240 minus 46 times 5. Okay, so now let us solve this. So this actually is 2 into 46 minus 9 into 40, 240 plus 45 times 46. Okay, so I'm just writing down it here. So essentially 2 equals to this, and this is 47. So 47 times 46 minus 9 times 240. Okay, so this is how we have expressed GCD of 240 comma 46 in the form of AX plus BY. So what is that equation? GCD of 240 comma 46 is basically 47 times 46 plus minus 9 times 240, right? So here the value of X is 47 and the value of Y is minus 9, and these two values are the additive inverse of 47 and 9. By the way, so this is how the extended Euclid algorithm can be used to express GCD in the terms of AX plus BY. Okay, I hope that is clear. But in case this is not, let us do this. Let us try out one more example so that it will be a bit more clear to everyone. Okay, so in the next example, let us say we want to compute the GCD of 101 and 8. Okay, so first let's compute the GCD of 101 and 8. So 108 and 1 is basically 12 times, right? Okay, 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 then 8, 5, all right, I'm so sorry, this is 3, 2, 3, 1 times, so 2, 1 twice, 2 times, and this will become 0. Okay, so now let us express it. Okay, so 101 is basically 12 times 8 plus 5. Similarly, 8 is equals to 5 times 1 plus 3, and 5 equals to 3 times 1 plus 2, and 3 equals to 2 times 1 plus 2. Okay, just let me highlight down. I'm just going through the yellow marked items. Okay, so far we have expressed 3. Now the other one is 2, so 2 is equals to 1 into 2 plus 0. So what is the GCD here? I am so sorry. Okay, yeah, so the GCD is 1, right? So this is our GCD. Okay, so again in the same way, what we can do is here 5 is equals to 101 minus 12 into 8. Similarly here 3 is equals to 8 minus 5. 2 equals to 5 minus 3. Okay, again 2 equals to 3 minus 2. Okay, okay, sorry, this is 1. I'm so sorry, this is 1, right? This is 1. So let's start from here. So 1 equals to, so now we are starting 1 equals to 3 minus 2. Now the from above equation we can say that 2 equals to 5 minus 3. So let us put that 1 equals to 3 minus 5 minus 3. So this becomes actually 1 equals to 2 times 3 minus 5. Okay. Now from here we know the value of 3 is this. So 1 equals to 2 times. So what is the value of 3? 3 is 8 minus 5. Minus 5. So 1 equals to 2 times 8 minus 3 times 5, right? 2 times here and 1 times here. So 1 equals to this, and from here we know that the 5 equals to this. So let us plug the value of 5 in this equation. So what do we get? 1 is equals to 2 into 8 minus 3 times, and what is the value of 5? 101 minus 12 into 8. Okay, so from here we can say that 1 is equals to 2 into 8 minus 3 times 101 plus what is that? 36 times 8. So this is actually 1 equals to 38 times 8, 36 and 2 minus 3 times 101. Okay, and that is how we express 101 and 8 in the form of ax plus by. So let me just write it down. So GCD of 101 and 8, we know that is 1, and this can be expressed in the form of 38 times 8 minus 3 times 101, right? So here the value of x and y are, so let me just write it down like this. X is equals to, okay, minus 3 and y equals to 38, and these are the additive inverse. Okay, by the way, the concept of additive inverse is not this. I'm sure you have some doubt on the additive inverse, but I'll do this. I'll make another video for additive inverse, because if I go ahead and try to explain the meaning of additive inverse in this video, then the extended Euclid algorithm video will become a very large video. So let us not do that. In case if you are interested in additive inverse, please drop down a comment and I'll definitely address that. That's all from this video. Thank you.